Hello, I'm Mark, and welcome to part 2 of my Unreal Engine tutorials on how to build an asynchronous and data-driven dialogue system for your Unreal Engine games. So in this video, we'll be covering the concepts of abstraction, interfaces, and base classes. And so we'll be creating an abstract orator class that will have which will house all the common functionality that is going to be used by both our AIs and our players, right? So we want to keep all the common stuff together, and so we're going to create an abstract class for that. We're also going to create an interface so that the system can understand, so we know who we can speak to and who we can't, and how to create that network. And then we'll also create a base class for our user dialogue. So without further ado, let's get started with a quick little recap of what we did in part 1. So in part 1, we went ahead and created our enumerators and data structures. So these are all the things that we're going to be building on top of to create our data-driven system, and also start creating that state machine that we'll be using to drive the conversation. So if you want to see what all of these are looking like, I'll leave a link to part 1 in the description below. Otherwise, we're going to go straight into part 2. So let's go ahead and create that abstract class. So to do that, I'm going to come over to the Unreal Engine editor. I'm going to come into the content drawer, and I'm going to come down to our C++ folder. And as you can see, if you're coming from part 1, we had a public folder here that we created a data structure in, but unfortunately, Unreal Engine doesn't seem to like data structures too much. So we're going to have, but it is there for us to use. So let's go ahead and just create our components. So to do that, I'm just going to right click and go to get a new class. And under here, we're going to use, under common classes, we're going to use the actor component, and I'm going to hit next. I'm going to make sure that we're in the right folder structure. So since we created our structures under public, I'm just going to click on that, hit select. So now we're in the public. So public, private, public folder, and I'm just going to keep everything together in that single folder for now. And I'm going to go ahead and call this the orator component. So this is the base class, or the abstract class, that we'll be building the player orator and the AI orator off. All right, so let's go ahead and we're going to hit create class and let Unreal Engine and Visual Studio do their thing, creating that template for us. And hopefully we'll get a good compile. Yep, good compile. All right, so let's move over to Visual Studio, and I'm just going to go ahead and reload. And as you can see, under our project, under public and private, we now have 2. We have the data structures, and now we have the components. So let's see what we've been created. So this is just the boilerplate that Unreal Engine created for us. And so what we're going to do is we're going to go ahead and build off this. So the first thing I'm going to add is a reference to our data structures. So I'm just going to go ahead and grab that include, since this system is going to be using that. So there's our data structures right there. All right, and then the next thing I'm going to do real quick is, because I want this to be an abstract, I don't want the editor to actually allow someone to grab this class as is. I'm just going to go and update the uClass tag. And what I'm going to do is I'm going to add this abstract in there. So what this is going to do is it's going to tell Unreal Editor that this is an abstract class, and so you can't use this component as is. If I was just strict C++, I could also make this a virtual class too, but we're just going to keep this as is. It's just a regular class. But we're going to be using this as an abstract. All right, so that should do it for the base setup of the class. So again, we're going to be using a lot of asynchronization in order to drive this dialogue system. And again, this is asynchronization between multiple entity types. So to do that, we're going to need some delegates, and we're going to be using a lot of them. So I'm just going to go grab the first set, and I'll grab the node as well. So this is for external communication. So these are going to be the delegates that we're going to be using for all of our entities within a conversation to talk to one another. And what we have here, and so the way Unreal Engine does it is you've got this macro so that it can create a delegate based on the target machine that it's going to be deployed on. Right, so we have our declare dynamic, and we're going to be using the declare dynamic multi-class delegate, and there's different ways that we can do this. We have 1 parameter macros. We also have a 0 parameter, which is down here, but if you wanted more than 1, then it's just 2 parameter with an S, and you can create 2 parameters, 3 parameters. I think you can create all the way up to 6 parameters. But for me, usually my general rule of thumb is you really don't need any more than maybe 2 parameters. If you're passing more than 2 arguments in, then you really should be moving up to passing that information through a struct, which is what we're going to be doing here on the second delegate. So what we have here is and I'll just walk through. We have the on orator speak begin call signature. So this is so we're breaking up the communication into a begin speak and an end speak. So on begin, the person who has the talking stick, the entity that has the talking stick, is going to send off a reference to themselves to everyone else in the group or who's part of this conversation. And by doing that, we're sending the speaker out, and that way if you've got entities, you could have them turn to talk to the person who's doing the communicating. For the player, if there's information that I want to get off them, and we'll get to that when we get to interfaces, I may want their dialogue logs, I can tap right into that and pull that information right off the speaker. And again, we're going to be so I'm just using the A actor pointer. So here we're just going to push a pointer out to everybody, and everyone can then use that pointer for whatever they need to do. On speak end call signature, right? This is the delegate that I'm going to be using for the response data, and this is the response data that we created over here in our data structures. So again, this is the state of the state machine. So response ID, new topic, as well as the enumerator. And that's what we're going to send just through this. And again, this will get sent out to everybody listening to this conversation who has an interest in this topic, and and this is how we pass the talking stick to the next person who's going to be working in this dialogue system. And this could go over to the player where they'll bring up their responses, or it could go to another AI which is part of this, or another entity which could then add more into this conversation. Then we also have the orator end call signature. So when we decide that we're done communicating through the system, so this could be on a topic change, or it could just be, okay, we're exiting out, we're done. Everyone needs to send communication so that everyone can drop the call. Okay, and this is how we'll then do our delegate cleanup, because we're only going to be building these things temporarily, and then once we're done, we want to clean things up. So that's how we'll communicate that we're cleaning up the call. And then I also have this on orator interrupt. So, we've seen it in a lot of other games, right? The first playthrough, you're riveted to that dialogue and everything that's being said, but then you're going through maybe a second playthrough, a third playthrough, and then you maybe want to skip through that dialogue, right? Skip. This is how we can then do that. So we can actually send that information out from the player and to skip dialogues, but we can also do an abort as well. And this could be very useful if you've got 2 entities talking and then suddenly they come under attack. We want them to stop that background conversation so they can go do whatever they need to do. And then if they want to then come back to the conversation again, they can come back. Otherwise, they can go off and do their thing, or they're probably dead. But that's how we can do that. So we can use this to abort from the player to the group, to any entity to say, look, I'm not interested in this conversation, or an entity to entity communication can also use this as well. All right, so these are for external communication, but we're also going to create some delegates for internal communication. And this is for event dispatching from the component back up to the component owner. This could be a character, it could be a pawn, or it could be a actor. So again, versatile component. So this is how we can then communicate back up again, all through event dispatching and asynchronous. Again, this one, so orator, response, action, call. So I just call these actions, that way I can distinguish them between what is being used for communication broadcast versus what is going to be bubbling up from the component back to the host. And so on orator action call, we're just going to be sending the state of the conversation back. So this is our enumerator, which is being housed in the orator response. And that state is right here. And so this will allow us to make a decision, right, on what we want to do. Are we continuing the conversation, or are we changing the topic, or are we exiting out to, are we done with the conversation, or are we going to be giving you a quest reward, allowing you to trade items between two people, or are we opening up the store so you can buy and sell your wares, things like that. And that's kind of how we're going to be controlling that. And then we have the on orator speak action, right? And then we have the on orator end action or call end. So this is going to be called when we actually finish everything up. But this one is actually going to be called on begin speak. So if there are things like maybe you want to bubble things up to the parent to say turn to face, right? You could do that. And again, this will all be bubbled up. And again, these are all going to be designed so that you can use them in blueprints as well as in the C++. All right, so again, just ignore the red squigglies for now, but that's kind of how we're setting things up. All right, so that's setting up the delegates so that they are defined. So now we need to go ahead and start setting things up in our class so that we can go ahead and use them. So to do that, I'm going to add them to our first public section. So as you can see, Unreal Engine creates a public section up here, and then it creates a public section and a protected section. So we'll stay within the structure. I actually like to put the events up here, so I'm just going to go bring them over. So the first set of events. So what we do is, again, you just use this because this is how we're going to be defining it. So that's the structure that it's going to create. There it is, and that's the name. So this is the actual name that we're actually going to be using, and I'm going to be using blueprint assignable. So when you're creating a delegate, you need to at least have the property on there, but if you make it blueprint assignable, then that makes this delegate here accessible for, but also accessible in the blueprint. So it's not just accessible in C++, you can also be accessed from the blueprints as well. So we'll just do that. So again, on begin speak, on end speak, on end conversation, and on end interrupt. And this will make more sense when we start getting into the concretes as well, and as we continue to start, and then as we start building out the AI and the player stuff, in videos 4 and 5. But we're setting up the groundwork now. And then, just like we did for the events, for the communication, we've also got our hooks back to the parents. And this isn't really the parent component. This is really the parent, the owner, which is the character, the actor, or the pawn. All right, and then again, on response action, on speaker action, and on conversation. So this allows us to bubble up as any additional things that we want to do based on how the state machine is rolling through the conversation. All right, and then lastly, within this section anyway, I'm just going to put this in public, but you could also put this in protected as well. This is the reference to the scripts topic table. So this is the table of topics that this particular entity which has this component is interested in. And so this is what we're going to use to determine so that we can start a conversation, but it's also going to be the table that is going to be determined who gets to join the communal conversation, right? So that's kind of how we're going to do this. All right, so that should do it for everything that we need for the public, and that's all of the delegates set up. So now let's come down to our protected section here and start filling in some variables we're going to need here. So just going to bring these over, and I'm going to put these above the begin play. So, like everything I like to do, I like to have the ability to turn debug messaging on and off from the blueprint. This can be very useful, especially when you're trying to debug things within a component that has a C++, a lot of logic in C++. So there's our debug messages. Going to set that to false by default. We've got two Boolean flags here. One is wants to talk, and the other one is going to be in conversation. And these are going to be very useful when we start creating the conversation networks, right? This one in particular, because this is what we're going to use to prevent us from going into indefinite loops when we start using recursive code. But then we also have the current topic ID as well as any new topic IDs. So again, this is information that we want to hold on to internally within the system. And then after that, I've got two enumerators that we're also going to be holding on to internally. Again, we've got the orator conversation state. So this is by default set to exit, and then the interrupt state, which is by default set to none. And then lastly, the last parameter that I want to have here in the protected section is going to be our orator script topic. So this is the current topic of conversation. All right, so, and again, this is the orator script topic. Again, this is generic. This is something that is common between both AIs and the players. All right, so after that, we're going to need some functions. And since this is a base class, I'm going to want some of these are going to be virtual. So the first one is going to be this cleanup on call end. So this is once we're done communicating and we want to clean things up, this is a function that's going to get called. And I'm making this virtual because there's going to be some things that are going to be common, but we can also add some unique stuff in here as well, so we can override this function as needed in the derivative classes. There's begin play, and then under begin play, I'm going to add 3 more functions, and we'll go ahead and start implementing these once we've finished the definition. So we'll come back and start to implement then. But again, so. This is just a utility function. Again, since we're using tables, I like to have a way of checking to make sure that that table has been referenced. Again, if we try and use a table that is not referenced, then the game crashes. So that's what I'm doing here to make sure that we don't crash the game. Then we have the orator script topic row. Again, we want to make sure that we want to get the current. So we're going to put the topic in, and we're going to go ahead and set this. This is a way for us to go get that topic row out. So again, just some standard utility functions there. And again, error messaging too, since we're going to be using this error messaging. This is just the little error message code I like to put in there. All right, so next we're going to come back to our public code. So we're not going to be using tick at all in this component. So again, we've got it there. It's one of the standards. We'll just keep it here for now, but we're not going to, it's overridden, but we're not going to do anything in it, just like begin play. But we are going to create our own virtual void response. And again, this is public, but it's not public it's only public internal. I'm not going to expose this to any blueprints for now. After this, I'm going to go ahead and create a virtual void nspeak. So this is going to be referenced through a blueprint, or can be referenced through a blueprint. And again, once again, it's virtual because ending speak for an AI can be slightly different from ending speak from a player. Then I'm going to add we're going to also add some internal, these are just some internal forced inlines. So we have, and again, these are going to be blueprint pures. So this is blueprint callable because this is void. This is blueprint pure because these actually return. So again, this is constant, which means this is a read-only function, and we're going to be returning wants to talk as well as in conversation. All right, next, as you can see, there's going to be a lot of functions in this abstract class. So next we've got blueprint callable, remove from conversation, and then we've also got end this conversation. Two different functions, but again, blueprint callable if they need to be called from blueprints. Once again, I got some more inlines. Just going to put them here. So this is the set interrupt state. So if we have an interrupt state, we can set it here. If we need to get the interrupt state, we can get it. So it's a getter setter, since it's protected and non-reference. There's no property setting. I'm just going to use a getter setter to get it and set it. And then we have the set current conversation state. So again, this is taking in our enumerator, which is defined in structures here, conversation state. And we're just setting that conversation state, where with the interrupt state, that's set here. And that's how we're going to set that up. And again, these are inliners, since they're just very, 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 very simple functions. And then I think this should do it for blueprint callable functions. So we also have get topic radius, and then we're also got try interrupt speaker. So get topic radius, again, because what's going to be controlling the radius for that radial cast from the entity, that is going to be done. That variable is actually sitting in the topic. It can be set per topic, and it's in the topic table, so we've got a little function to help get that. And then we have the try interrupt speaker. This is what we actually call in order to cast out, send out the interrupt broadcast. And then finally, we've got some more utility functions, internal utility functions. We've got get new topic ID, and again, this is a name. So topic IDs, these are all F names, and so this is the new topic ID. We have the add to conversation, so if we want to add to a conversation, we've got to add to a conversation based on the topic ID. Has script topic, again, this is a great way for us to figure out if we have this topic ID. So if we don't, then we don't need to be part of this conversation. If we do, then we need to add ourselves to the conversation. And again, once again, I have the is debug, and I've just left this a boolean. So again, it's a const, and all we're doing is just returning this if we want to check for it. All right, so that is the abstract signature. And so let's go ahead and go into implementation. So what I'm going to do is I'm just going to go ahead and fix these all first, and then we'll just walk through the implementation. And this one. And this one. All right, we're getting close to the end of these green squigglies. All right, so let's go ahead and start with the implementation now. So first off, I'm actually going to set this to false, because this component, we shouldn't be using any tick functionality at all within this component. So by setting it to false, even if in the blueprint I click on has tick, right, it's not going to tick because this will actually kill it. So we're just saying this component can never ever tick, even if you try to get it to tick in the blueprint. So that's done. We don't need anything else in the constructor. So now let's go to our first function here. So we have onCall end. So what we're going to do here on onCall end is two things. So this is, again, these are things that are going to be common between both the cleaning up, ending a conversation for AIs, as well as ending the conversation for the player. So the first thing we'll do is we're going to set our conversation state to exit, and then what we'll do is then we'll blast out a broadcast on end conversation end action. So again, this is an action. We're broadcasting. We're actually going to be broadcasting up to us. So this is bubbling up an event back up to the actor, character, or pawn, right? And then if there's anything that you want to do, either in script or in C++, within the character, within the host itself, then it can go ahead and do that right off this call, if it's listening to this call. All right, not going to do anything in begin play. All right, is a valid table. So again, I created this function after so that I can manage my data tables. Oops, no, wrong one. This is the one I want. There we go. So is valid table. So again, this is our reference to our table. We're going to check to make sure it's not null. If it is null, we'll then go ahead, fire up a message if we're listening for it, and we'll then return false. Otherwise, if it's correctly been set, then we'll return true, and we can use saying we can use this table, or that there is a table attached to it. Doesn't necessarily mean it's the right table, but there's a table attached to it. All right, so that is valid table. So after that, again, we want to say get current topic. So this is the one I accidentally brought over. So this is our current topic. So this is how we're going to go ahead and try and get our current topic. So get current topic. So we're going to take the topic ID in, check to make sure our table is valid. If our table is valid, then we're going to go ahead and try and find this topic. Now, if this topic does not exist in this table, it's going to return null. Otherwise, if it is, it will actually return this a reference to this struct here. If it's invalid, again, we'll return null. So as long as we have something, we'll have something. Otherwise, we return null, and it's all being done over pointer reference. So there we are, a little star there to say it's a pointer. Okie dokie. And let's do our error message. So again, since I've got some debugging messages in here, I want to take advantage of that. There we have it. It's just void, check, and then if the engine is valid, we'll go ahead and execute this add-on screen message. Again, this is pretty much standard for anything that I'm working on. So there it is. All right, so now we're coming down, we have tick components. So I'm just going to go ahead and minimize tick component since we're not doing anything on tick. We have response. So this is a virtual function which actually we want the concretes, the derivatives of these classes to actually use. So what I'm going to do is I'm just going to put a message there. That way, if this fires up and you've got debugging turned on and you see it means you haven't actually implemented this in the concrete. And I'm going to do the same thing for end speak as well. Respond, end speak. All right, next is going to be remove from conversation. So I'm just going to copy this. So first, let's check to see if we're in the conversation. If we are in the conversation, then we're going to go ahead. So because we're using all these delegates for our to broker our communication, right? We want to clear them all. So if I want to remove everybody who's attached to me, I'm going to say clear. So what this does is it's going to remove everybody that is attached to me. so that if once I do this, if I do broadcast again, it's not going to go anywhere. So I'm clearing up anyone who's attached to me on my delegates. I'm also going to set in conversation to false, so this will allow me to now join a new conversation if a new conversation is available. And wants to talk is also going to be set to false. Current topic ID, I'm just going to null that out, and then I'm also going to set interrupt to none. And then after that's all done, we're going to then come back up here and do clean up on call end, which is going to then set the exit state to exit, and then broadcast the end action. So there we have it. That's everything to remove from conversation. And then we have end this conversation. So end this conversation does two things. First, it's going to broadcast out to everybody listening that we're ending the conversation. So this is the terminator, which will then terminate all conversations within this temporary conversation network we've created. So this will broadcast this, and anyone listening will then start going through the removal process on their own to help clean this up, and then there it is, removed from conversation. So first we're going to broadcast out to everybody, and we're going to do that while everybody is still listening, right? So we need to do this first, do the broadcast. Once we're done with the broadcast, then we can now go to removal of the conversation. So order of operation does matter here. We need to broadcast out first, and then we'll go ahead and remove everybody from our delegates, or once we're done. All right, get topic radius. So again, we'll see this in action when we get to, I think, the next video, part 3, where we create the concretes and then start integrate them into the host entities. So let's just go ahead and minimize this real quick. But again, this is just simple. It's going to check to see if we have the script topic. If we have a script topic, let's go find that radius and pass it back. If we don't have a script topic, then we're just going to pass back 0. Pretty simple there. All right, try interrupt speaker. So this is, I like to put a try on there if it's actually going to run something. So again, this is something that's going to get called. It can be called from me, it can be called from the EAI, but this is what's going to initiate the broadcast on the interrupt speaker. So what we do is we take the state, the enumeration state, set that, and then I'm going to go ahead and broadcast this out to everybody that's listening that we're interrupting the speaker. And this could be if I want to skip through the dialogue, right, or the speaker's dialogue, tell them to hurry up, or we want to abort the conversation because we no longer care, or something's come up and we need to terminate it quick. So that's what's going to happen there. Alrighty. And so we're coming down to the last 2. We have add to conversation. Again, we'll see this in action in the next part. But then this is add to conversation. So this is how we add ourselves to a conversation. So we're going to pass the topic ID in. We're going to say yes. When this gets called, we're going to say yes, we're in a conversation now. Yes, we want to talk. And our current topic ID. This is the topic of conversation that we're interested in. And we're going to go ahead and set our interrupt sets. Make sure this is set to none. So, and then finally we have has script topic. So I'm just going to go ahead and do that. So this is the has script topic. So this is a check to see if we have any interest in this. So usually this will get done first, and if we do have any interest, we can add ourselves to the conversation, versus if we don't have an interest in this topic, we'll just say nah, we're good, thanks. And so it's a Boolean check. So we're going to say get current topic script, get that out there, check to make sure it's not null. And then if it's not null, what we're going to do is we're going to say make the topic ID the same topic ID. So again, this is we're just taking this topic ID and putting it in there and returning a true back to say yes, we're interested in this conversation. Otherwise, if we're not, we're going to return false, and then this entity is just going to ignore the conversation. All right. So that should do it for the implementation. So that is our abstract class. So now I want to move over to our interfaces. So first, let's go ahead and make sure we've got a good compile, and then we'll go ahead and start setting up our interface. All right, so let's go back to the editor real quick, and let's run the compile. Make sure everything's good. All right, it's happy with our components. So let's go ahead and create an interface. So I'm going to be creating a C++ interface for this system. So to do that, again, we're going to come back to our core Orator Live, and now that we've got a component in here, it's given us a public folder. So under public, I'm going to right-click, go to New Class, and at the bottom we have Unreal Interface. So this is going to create an Unreal interface for us in C++. So I'm going to hit Next. And let's give this a name, and I'm just going to call this Orator Interface. It's going to go into the public folder, so just make sure everything is good. And then I'm going to say create class, and this is going to go ahead and create our interface for us. All right. Okie dokie, so let's go see what's been created. So let's go reload all. All right, so for interfaces, so if anyone asks you what is the similarities and differences between an interface, right? One of the core differences is that an interface has no implementation, where an abstract class does. So since we have no implementation, I'm just going to close the implementation file. So what this really is this is just a definition of functions that we should be expecting to see on the entity that is on a class, right, that is implementing this interface. So what I'm going to do is I'm just going to bring them all over real quick, and we can discuss them. And as you can see, we've got some red squigglies here, so we need some data. So I'm just going to go do that too. All right, so again, Orator data structures. So as you can see here, Unreal Engine goes and creates us the standard Orator interface, but it also creates this Orator interface uObject. We don't need that, so don't delete it, but as it suggests up here, does not need to be modified, so we're not going to modify it. The part that does need to be modified is down here, and I've just gone ahead and added the functions. So these are all the functions that I've decided to include in the interface. And again, as you can see, there's every one in here is virtual, and all of them have this equals 0. So this is C++'s way of saying that this is a purely virtual class. It has no implementation. So we have to, if we have a class that references this, we must override it in order, so that we can use it. All right, and again, this is just all it is just a signature, right? So the first one is the Orator component itself, and I'm just using a class here. That way, if when the linker happens, if it's not in the include, it'll breeze over it, and it will link it up when it's ready to link, when it comes across it during the linkage process. All right, so again, this is our abstract class that we created. So if we come back over to here, so here is our abstract Orator component. Here is our interface. So that's the class, and I'm doing it this way just so, because we have this concept of flavor, but during the communication setup process, we only care about the abstract, we don't care about the concrete. So that's why I created this function. So we'll get into this in part 3 when we start creating the communication network. This is the peer-to-peer. So if I have an AI that wants to flag me down, or if I want to have two AIs having a private conversation in the background, they could use peer-to-peer, in which their perception system picks each other up, and it goes ahead and says, hey, this is the topic I want to talk about, and hey, this is who you are. Okay, this is someone that I, through my AI perception system, I see you, and I want to have a conversation with you. You could do that, and you could then kick off a conversation here, and I do it through peer-to-peer. Versus this is the group conversation. So this is usually for me kicking it off from my interaction system. So I'll go up to someone, and so at that point I'm using join conversation group. It's just a little bit more effective, and we'll get into the implementation of this in part 3. We're just defining the interface right now. Then we have our 4 events here. So again, these are going to be binding to the communication listeners. So that's them defined there. Again, listen to speaker, there it is. Here's the response. Here's the orator conversation ends, if we need to do anything there, and as well as listen to interrupt speaker. And then finally, I've got 2 more functions, and these are more useful for when I get into the widget, right? We want to see the lines. So because on begin speak I'm passing an actor, I need to get access to their lines. So since I'm passing the actor and I know that this actor is going to have this interface, I can then just call a function on that actor, right, to say get the lines, and it will show me the dialogue lines. And that actor should also have a get character name or get actor name. I might want to change that later. So, but this is getting the actor's name that I can then use in my dialog box to say who's speaking. All right, so that's going to do it for interfaces. So next up, let's go ahead and define our base class for our dialog widget. All right, so again, I'm just going to come back. I'm just going to do a quick compile to make sure everything is good before we start adding an extra class. We're good. So let's go and do the widget. So to create a custom user widget in C++, what we're going to do is we're just going to come down to public. I'm going to right click, go to new. As you can see here, there really isn't an option, but that's okay. So what I'm going to do is I'm just going to come to all classes, and under all classes, I'm just going to say you use, or actually I'm just going to say user widget. And as you can see here, we've got visual widget, user widget. So user widget, this is the one we want. So from here, I'm going to go ahead and hit next. And we're going to go ahead and give this widget a name. So again, I'm going to call it orator base dialog widget. It's part of public private. So it's going to go in there. I'm going to say, hey, create class, and we will let Unreal Engine and Visual Studio do their thing. And it's going to go ahead and compile it. Once I get a good compile, we can go check it out. All right, so let's go check it out. Reload all, so it reloads it into the structure over here. All right, so this is our dialog widget. And so when we do that, we'll get this user widget here. And this is the kind of like the base setup. So in order for us to create our widget, I'm going to add a couple of includes. So this is specifically for our dialog system. So I've got components text blocks. So this is going to be useful. So so this widget's going to be doing all the dialog pacing for the as well as handling the switching. So there's going to be a lot of functionality, and I decided to put this into C++ just to make it just better to access. So components, I'm going to be using text blocks under the components. So this will allow. So I'm going to be doing this because I want to create bindings between the C++ class and the widget or the blueprint widget that we're actually going to be creating. So this is the base class. We're going to be creating a concrete that we're going to be putting on top to actually run this. So we're going to use text blocks, but then I'm also going to use the orator structs because, again, this is going to be how we're going to be interacting with the state machine as far as the player is concerned. So another thing I'm going to do is I'm going to add an enumerator. This is the orator dialog state. So within this dialog box, we're going to have two states. We're going to have it set up so that we can see the dialogue rolling across the screen as we're simulating that character, the entity speaking. So that's the speaking mode. But then we also have the orator dialog state for replying. This will then bring up a widget which will allow us to pick a response that we want to send out to everybody. And then we also have an off state too. So again, dialog state, speak, reply, and off. All right, next. So just like everything else, we're going to create some multicast delegates. These are both one parameters. And this is going to be the orator player responses structure. So again, this is coming from the component structure. So I'll just go bring that up real quick. So again, orator player responses here, since this is a widget that is very much tailored for us to allow us to interact with the conversation. And again, that's a data, and it's a one parameter. And then we're also going to have the interrupt state. And again, I'm making this a delegate so that, so that it can be, we can interact with it from the blueprints, and then it will broadcast back to the component. So again, this allows us to create communication between the orator components that is managing the workflow in the state machine, right? The dialog workflow and the UI. So here we are. And again, this is all asynchronous. All right, so under here, we've got some setup that we need to do. So I'm just going to go ahead and set this up. So we've got a public. And I'm going to have a protected section. And I'm going to have another public. All right, so I'm just going to set that up. So in this public section, I'm going to we're going to add we're going to go ahead and add the callbacks to our delegates here. So again, I'm just going to hit save. As you can see, Visual Studio's doing its thing. It's still thinking about these right now. Eventually it'll figure it out. So we have our on reply finish, and then we have our on speaker interrupt. And then we're also going to add two properties. And these two properties are actually going to be bound to the blueprint widget when we create it. And so that's why I'm using txt orator name and txt dialog. And so, and as you can see, we actually have in this meta on the property here, bind widget. So this is how we can create entity or text block entities, right, in C++, but we can then bind them directly to the UI that we're creating in the blueprint editor. So we'll see how this works when we in part 3, in the next part, when we actually go ahead and we're actually part 4, I think, when we actually create the actual blueprint widgets. So we'll bring this up, but again, this is how we're doing it. So this could be very useful if you want to create like, more complex widgets where you want a lot of the code to run in C++, but then you want to surface information up to elements in the UI. You would just have to then use the meta bind widget, and that will then bind that to it. So we'll see that in action, I think, in part 4. All right, so next up, we've got a lot of public properties and functions, since this is going to be managing the dialog state of this widget. So first off, I'm going to bring in all of the properties. So again, so what we have here is we have dialog lines, which is going to be an array of f texts. So these are the lines that an entity is speaking during the conversation. And this is a list of all the responses that me as the player, if I have responses to that, can give you if it's my turn to participate in this conversation. We have a line index. This is again used for iterating through the lines. It's blueprint read only, but it's kind of internal, so we don't have any ways. We don't really want to have any way of setting it, so I've got rid of the edit anywhere. And then we have line pacing. So this is how quickly we want to move from line to line to line. So if it's got multiple lines, as seen in the Apple's Quest, right, we can pace ourselves between those lines. I put 1.5, that's worked for me, but if you want something a little bit longer, you can put that in. But again, I'm making this edit anywhere, so we can actually change this value in the blueprint widget, so we don't necessarily have to come back here and recompile. But this is the only value that we need within the blueprint widget, or the widget blueprint, to change if we want to change it for customization. All right, and then again, we have the orator dialog state, and this is going to determine whether we're going to be showing lines of scrolling text, or if we're going to bring up the ability for the user to be able to choose what they want. All right, internally, we're going to have a time handle, and that's going to be on a delay right here. So the way that the system's going to work is, again, I'm using pacing. So because I'm going to be running this from C++, we don't have a in Blueprints. You've got the delay boxed. In here, we're going to be using timers. It's just how we do it in C++. So to do that, we need the delay time handle there. Let's go ahead and just bring all these functions in, and we can walk through them. All right, so we've got a lot of functions here. So we've got the on-call done. This is just a function that gets done when we're finished. We have the iterate through lines. This is going to be the function that's going to be iterating through the lines. On-call response select. So this is a function that I like to do. This is what I like to do when I'm hooking up delegates. So I like to create a wrapper around it. So all we're going to do is, so we just have to call it as if it's a regular function from the blueprints, and we just pass this information in, and it will then handle the broadcast. So this is going to be call on response select, and this is call on response interrupt. And then we've got the set dialog state. So the set dialog state, again, this allows us to set the state, whether we're going to be in speaking mode or replying mode. And then lastly, we have these 4 functions here, and they're actually using Blueprint native events. So if you've never used these, this is a pretty neat trick, which allows me to execute code from C++ in a blueprint. So we actually build blueprints on top of C++, but if I have something that's running in C++ which I want to then bubble up to the blueprint to then have it execute an event, we can do that through these blueprint natives. But we can also execute some C++ in there as well. So that's what I've got here as well. For this widget, I'm not going to do anything with it, but if you wanted to then say execute some code and then bubble up, you could do that from here, and then it will execute that. But Unreal Engine will create, when it compiles, it will create those hooks for us. But these are pretty neat, and we're going to do this for on speaker, on reply, as well as set the off state. Again, they're all native events. And then finally, we have this line complete pace. So this is again something that we can use to help with the pacing of those dialog lines. And then finally, I'm going to come to public again, and then within public. So this is the speaker and replies functions, and as you can see here, on speak, we're going to put the lines and the name. So these are the dialog lines, and this is the name of the character that's speaking, or the entity that's speaking. And then this is the replies. This is my choices that I can choose from. So, and these are going to be, I think, set from the this actually gets set from the orator, the player orator component when we get to that. So we'll see that there, I think. All right, so let's go ahead and do the implementation. And to do that, let's go ahead and fix these green squigglies. So I'm going to do that for that one. Do that for that one. Do that for that. And do this one for this one. All right, so when it comes to native events, you want to leave this as is. This is the only one which we want to fix, which is the implementation. So I'm just going to go do that. Oops, no. So the only, so leave these screens as they are. If you go ahead try and implement it, then the native binding doesn't work. So we want to keep that there, so that we can use the native event instead. And then line complete pacing. So I'm just going to go ahead and do that. And then speaker and replies. All right, so that's that. So let's go ahead and fill these in. All right, so starting from the top, all this one is going to do is it's just going to go ahead and set this line index back to 0. So when all is said and done, we just want to make sure that this is reinitialized back to 0. And the reason why I'm doing it this way is because our line pacing is actually going to be done, again, asynchronously through a timer. And so because of that, we can't keep that within the function. So we need to keep a track of this outside of that. All right, so iterate through lines is next. So let's go grab that. And so this is the iterator. So the first thing we're going to do is we're going to make sure that we set the dialog text to blank. And then what we'll do is we'll check to first make sure that we have dialog lines to iterate through. And then what we're going to then do is we're going to set the dialog lines based on the iterator. Since arrays are 0 based, we need to start in the 0 position. And then as we keep going through line complete pacing, it will then go. So what we're doing here is we're just setting the text. So, and then we're just putting a wait handler on the complete line pacing. So, and then if number is 0, right? We don't have any, we're just going to automatically just go to on call done. I'm just going to come down to complete line pacing so we can kind of finish this off a little bit and see what's going on in there. So all complete line pacing does is it goes and checks to see if we're finished with all of the dialog lines. So it's going to say, is the index greater than or equal to the number of dialog lines in the array -1? If it is, then call done. If it isn't, which means that it's less than, it means that there's still more dialog lines in the array that we want to iterate through. So we'll just increment it. So we'll just use this overloaded ++, and then we'll just call iterate through lines recursively. So this is a recursion, a recursive function, and then that will call complete pacing again after it's set the new lines in place. All right, so that's all that's done. So I'm just going to minimize that one, and I can minimize this and minimize that. All right, so the next set of functions are just some simple kind of relay functions. So this one is on-call response select. So all it's going to do is it's going to say anything that's listening to on-reply finish just broadcast to, and it's just going to broadcast again the player response data. So if I select something, I'm going to click on it, and then it's just going to broadcast that back to the rest of the group in the conversation, so that they can, so we can then pass that to whoever needs to respond to it. On-call speaker interrupt. Again, if I need to interrupt it from the UI as the player, I can call this, and it will just pass in the state, whether we're doing an abort or a skip. Set dialog state. So what we're going to do here is we're going to take the dialog state and hold on to it, but then we're going to run through this switch statement here. Dialog state. Just going to go ahead and just tab that in. So on dialog state, we're going to take a look at the enumerator. So if the dialog state is set to speak, right, we're going to execute this native event, which will then execute this whatever is listening to it in the blueprints. Set for replies or off state. So again, we're just going to execute the native events, and we'll let the native events in the blueprint widget manage the UI. All right, as far as for implementation, not going to do anything there. We don't have anything tied to it. We've done line pacing. So we just need to go ahead and do the final two public functions. So for speaker, and these two functions are being called from will be called from within the player orator component when we create that, and we'll be doing that in the next video. But again, here's the speaker. So what we do is we pass in an array of lines, and we're also going to pass in the name. So here we are, we're just going to say set the lines internally so that we can iterate through them, and then set the orator name, and then we're going to set the dialog state to speaker, and then that will kick everything off for us. But if the state machine is set to choices, I've got the talking stick and the entity and none of the entities in the conversation do, then we'll bring in the choices, and then we'll set the dialog state to those choices here. And again, this one will then fire off set for replier. All right. So that should do it for all of our abstract classes, interfaces, and base widget classes for this tutorial. In the next video, I'm going to go ahead and we'll go ahead and build out the concretes for both the AI and the player, and then we'll go ahead and also integrate the player and the AI orator components into their respective entities. So that's what we'll do there. That's in video 3. Video 4, we'll go back and it'll be all things player. So we'll come back to this base class here, this widget, and we'll go ahead and create the blueprint version of it off this base class, and then tie that into the player, as well as setting up a simple interaction system so that our player can interact with the AIs and kick off communication. And then in video 5, that will be everything AI, so we'll go ahead and create the AI version of the blueprints, show you how you can set that up, and then we'll create some simple little dialogues that we can run through the system. Alright, so as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. And if you have any questions, feel free to leave them in the comments below, and I'll see you again in the next video. Cheers, and have a good day.